So these are the objectives we're going to be going over today, guys. You can go ahead and read them, take a picture of it, write them down, whatever you like.
What chapter is it?
We are in 3.1 today. So we are in 3.1. I think it's a pretty short chapter too. That's all we have for the week. So it shouldn't be that bad. Do you have a stapler? Okay. Okay. So, are y'all done copying this done, or are you also writing? You good? Okay. So we have some vocabulary to kind of go over. One thing is what a statement is. A statement is a sentence that is either true or false, but not both simultaneously. These are some examples of statements. London is the capital of England. William Shakespeare wrote the television series, The Big Bang Theory. That's all one statement. William Shakespeare wrote the television series, The Big Bang Theory. So that one's obviously false. And London is the capital of England. That's true. So that's what it means to be a statement. You can say it's true or not true. All right. There's no objectivity, if that's a word. There's nothing objective about it. It's either true or not true. All right. These are examples of what are not statements. So stuff like think before you ask or you speak. That's an order or a command. It is what it is annoy you in everyday conversation? That's a question. Smartphones are making us stupid. That's an opinion. Right? These are all opinions or commands or something else. It's not something you can say that is true or that is false. A statement is a true or false statement, not anything else. All right. So we have symbols to represent statements. In symbolic logic, we use lowercase letters such as P, Q, R, and S to represent statements. Here are two examples. P, London is the capital of England. Q, William Shakespeare wrote the television series, The Big Bang Theory. The letter P represents the first statement, the letter Q represents the second, and then R and S would be other statements, right? So kind of like how in math we write, well, this is math, but like in algebra we kind of say X equals 5 or something like that. You can do the same thing with these kind of logic statements. You can say, well, P equals that statement, and Q equals the other statement, right? And then from there you can say P is true and Q is false. Am I recording though? Yes. Okay. Negating a statement, that is when you can kind of rewrite something to make it the opposite. So if you have a true statement, you can make it a false statement. And same thing with a false statement, make it into a true statement, right? So if you look at London is the capital of England, you can negate it by saying London is not the capital of England. You give it the other meaning of it, that's negating it. Or William Shakespeare wrote the television series The Big Bang Theory. Say William Shakespeare did not write the television series The Big Bang Theory. That's what negating is. You're kind of just flipping it from a true to a false statement or a false to a true statement. All right. Any questions about anything so far? Are we good? Okay. So form of negations. Form of negation, Shakespeare wrote the television. So yeah, it's kind of what we said, right? It's just kind of putting a not in there somewhere, kind of just finding a way to change its truth value without changing the meaning or really like the hypothesis or the conclusion of the statement, right? Or not, I guess not hypothesis, conclusion, but without changing what you're talking about. You're just changing the truth value, but not changing kind of the statement itself. All right. So more forming negations. So form the negation of each statement. Today is not Monday. It is true that today is not Monday. Today is Monday, right? So you can kind of say it different ways. If today is not Monday is the statement, well, the negation of that is not true, or today is Monday. It is not true that today's not Monday is another negation. You're putting two nots, so it kind of cancels each other out to just say it is Monday, right? It is not true that today is not Monday. It's saying it's false that today is not Monday, so it's saying it is Monday. It's kind of like English class, I guess, but you're kind of playing around with words to kind of say the opposite of what this original statement was. All right. Expressing negation symbolically. That curvy thing you see on the bottom, that, what's it called in English, like a tilde or something like that, that means not. So not P and not Q, that's where you're negating its truth value, right? So if P was true, right? So if P is true, this symbol, the squiggly line in the P means not true. Okay? So it's been kind of like a bunch of, I guess you can kind of say common sense, right? Of statements, true or not true statements. But here comes the math part of it, where you start having symbols and you start saying P is true. You can say not P is not true. All right? That's really all it is to it. All right. And translating a symbolic statement into words. So, let P represent the following statement. The United States has the world's highest divorce rate. Express the symbolic statement not P in words. So, the symbol that is translated as not. Therefore, not P, the United States does not have the world's highest divorce rate. You can also say it as it is not true that the United States has the world's highest divorce rate. Right? Is this making sense there, guys? Are you okay? Okay. Now, quantified statements. So quantifiers, the words all, some, or no, or none, are quantifiers. All poets are writers. Some poets are generous. No common colds are fatal. Some students do not work hard. So these are not just kind of definitive statements anymore. Now they're kind of putting quantifiers, all of them, some of them, none of them, right? And these are important words in math, especially when we start actually putting math into this, because we have special symbols to talk about all, some, or none, right? So, equivalent ways of expressing quantified statements. All A are B. An equivalent way, there are no A that are not B. These distinctions are kind of important when it comes to math because we do have special symbols where you should be able to go back and forth between the two. All right? So all A are B. You can kind of say that as, well, negating both of them. There are no A that are not B, right? This one's saying A is B. This is saying not A. Yes, 3.1. Right? Not A and not B, right? That's kind of what it's saying. All poets are writers. That's all A are B. All poets are writers. All A are B. There are no poets that are not writers. There are not A that are not B, right? Not A, not B. Everyone following me? So, kind of. We're kind of playing around with words, pretty much what we're doing. Right? Hopefully when we get some math in it, it'll start making a little more sense. But we're just kind of negating stuff, right? If you put two no's into a statement, they kind of cancel each other out, right? There are no A's that are not B. The no and the not cancel each other out. You're kind of just back at the original, right? Two negations kind of cancel each other out. Some A are B. There exists at least one A that is B. That is a B. This middle part is kind of how we say it in math. If you say some A are B, we say there exists at least one A that is B, right? This is kind of an important one. It's kind of the one that's always kind of tricky when it comes to actually some mathematical statements, right? This is the tricky one because when it comes to math, we don't really have like some and most and stuff like that, or we really just have everything is A, everything is B, or there's at least one A that is B. So not all the A's, but at least one, right? Does that kind of make sense what I'm saying, guys? So we don't care about majorities or most or halves or quarters. We just care are they A's or B's, and is there at least one A that is a B, right? Maybe not all the A's are B's, but at least one of them are. Then we use at least one, or we use some. No A are B, all A are not B, right? And then some A are not B, not all A are B. So that's another important one, because the word some is always the one that's confusing, because when people think some, they think more of one. But when we talk about some in math, we really just mean at least one. That's kind of the best way to think about it. In math, some just really means at least one. Yes.
So we're on
3.1.
Yeah, 3.1.
We kind of breezed through a lot of it, because a lot of it's kind of just,
Statements.
yeah, we're on
Statements. Is it like not like a summary of what?
basically all we've talked about is a statement is a true or false statement. So something's either true or not. When we say statement, we mean it's true or not true, right? Like saying you are a student of my class, that's a true statement. But then saying you are the best student of my class, that's objective. That's not a true or false statement, because best in comparison to what? You know what I mean? That's kind of the difference between a statement and just an opinion or something like that.
Statement objective.
I would say a statement is objective, like it is true or it is false. You are a student of my class, that's true, right? You are a student of my class. Or if I say you are not a student of my class, that's false. You are a student of my class, right? It's a true and a false statement.
Wait, what's the difference between statement and objective?
They're not really related. Say they're different. It's more just objective means it has a fact behind it, right? The statement is an objective statement, means it has a true. It's either true or false. There's no ambiguity with it, right? It's either true. It's either yes, it's true, or no, it's false. And then we're talking about sum now. The word sum in math, it really just means at least one. That's really all it means in math. And that's kind of like a really loose definition of what sum really means in math, but I think it's kind of good in layman terms what that kind of means. It just really means at least one. All right. So let's look at this. Negation of quantified statements. The statements diagonally opposite each other are negations. All A are B. Some A are not B. These are negations. There are no A that are not B. Some A are not B. Not all A are B. Right? So sums can still negate the word all, because if all A's are B's, well, if some of them are B, that's still kind of the opposite of it, right? They still kind of cancel each other out. One's true. If some of them are still A's, well, then that's a negation. It's not true anymore, right? If no A's are B's, well, it doesn't just need to be all of A's or B's. You can just have at least one. If at least one A is a B, all of a sudden no A's or B's is all of a sudden a false statement. That's kind of confusing. That's why I'm saying the word sum can be a little confusing in math, because we really just mean at least one. Does that make sense what I'm saying? You don't think, not really?
Can you repeat it?
So basically, when we say all A or B, or let's say all of you are my students, right? Let's say that's a statement. That's a true statement. All y'all are signed up for my class, you're all my students. Let's say one student walks in and sits down in my class that isn't signed up. All of a sudden, that previous statement I said is false now, right? Because not all of y'all will be my students anymore. That means that's also negation. Negation just doesn't mean to be complete opposites, right? That's pretty much what it means, right? Even just at least one of y'all are not my students, all of a sudden my statement is false, that negates it. Basically, negation doesn't need to be a complete opposite, right? It doesn't mean all of y'all are my students or none of y'all are my students. You could be somewhere in the middle saying, well, all of y'all are my students, or maybe most of y'all are. That kind of makes sense what I'm saying? Again, it's kind of like math class, English class, we're kind of nitpicking these little words, but that's logic in math. All right. And these are some pictures of what they mean. I can make this a little bigger. All right, so if we're talking, you can barely see that. So poets and writers, if we say all writers are poets, can y'all read that or not really? It's kind of hard to read. Hard to read? I'm just going to read it. So if we have a statement like right here, we say, let's say this is the set of poets, and then we have a smaller set inside of writers, right? If you think about subsets, here we're saying all writers are poets, right? That's true. Every single writer in this red set that I drew, these are all poets, right? All writers are poets, right? I don't care if it's true or not, but this is kind of what I'm saying here, right? All writers are poets. That's the statement saying here. And that's a true statement. So if I wanted to negate this and I wanted to prove this false, I can do this right here. I can just say, well, what if these were poets and then these are writers? So the second statement, this second picture I drew, that's a negation of the first. Because if my statement is all writers are poets, that's my statement. That has to be a true statement. And this one's true, and this one's false. All I care about is changing that truth to a false. If I change it from true to false, you negate it. It doesn't matter how you negate it, as long as it gets negated. As long as you make a true statement to a false statement, it does not need to be like this, right? It does not need to be two completely different things like this. These are both negations, so if I kind of box this statement right here, this is one negation of the original. This is another negation of the original, right? And that's what it means. These are both, the bottom one and one on the right, these are both negations of the original statement, right? If my original statement was all writers are poets, well, these are both negations. Even though one says no writers are poets, that's a negation, but this other one says some writers are poets. That's a negation because that both proved my original statement false. Make more sense, guys? We're still kind of confusing. So basically, when you try to negate something, it isn't about just doing the complete opposite, right? You don't need to go from all writers are poets to no writers are poets. You don't need to go from one extreme to the other. You can kind of go in the middle to prove my statement wrong. Right? If my original statement is all writers are poets, you can just say, well, some writers aren't poets. Only some writers are poets. That negates it because it still makes my original statement false. Right? And then this one also negates it because they're both proving my thing false. You're trying to just word it in a way to prove me false. It doesn't need to be a complete 180, a complete opposite saying, no, not all writers are poets. Just some of them are. Kind of make sense? It's weird. Sorry? Okay. All right. So, negating a quantified statement, manufacturer of my smartphone told me all known safety issues have been resolved. I later learned that the manufacturer never tells the truth. What can I conclude? All right. So, begin with the manufacturer's statement. All known safety issues have been resolved. Because the manufacturer never tells the truth, I conclude that the truth is the negation of what was told. So, what is a negation I can say about that? Can I conclude that all of them have been solved? All the issues have been solved? No, right? Because the original statement is all known issues have been resolved.
So in order to answer that, say, how are you supposed to answer it? Say either a statement or
Yeah, but we're asking what can we conclude from this? If the manufacturer of the smartphone, right? Or let's do like this. Let's say maybe an easier example would be like this. Let's say I told you guys I've graded all your tests. But let's say I'm always a liar. I'm always lying about what I say. Right? So everything I say you have to think, well, I'm lying. Well, what can you conclude? Are all the tests graded?
no,
How many are graded?
not all.
Not all of them. That's exactly what we're getting at here. So if I'm a liar and everything I say is a lie, and I say all the tests are graded, that doesn't mean none of the tests are graded. That just means not all of them are graded. They're both They're both proving me wrong. They're both saying they're both proving that I'm lying, but they're saying it in different ways, right? You don't need to go to the complete opposite extreme to prove that to negate what I'm saying. To say I'm a liar. It's pretty much what I'm saying, right? So the negation of all A or B is some A or not B. So in this case, you can conclude that some known safety issues have been resolved, or at least one safety issue has been resolved. So if this guy tells you everything in your phone is fixed, and you know he's a liar and everything he says is wrong, you can conclude, well, at least one safety issue has not been resolved. So at least one hasn't been resolved, or maybe all of them hasn't been resolved, or just some of them has been resolved, right? It doesn't need to be everything, nothing got resolved. It can just be kind of in the middle, like you said. Like my example of the test being graded, if I said all of them are graded and I'm a liar, that just means, well, at least one of them has not been graded, either one or all or just half or whatever. Does that make sense, guys? Any questions about what I'm saying? Okay. Is that really it? If that's it, that's I thought I had more than this, at least. No, there's some more. I think. We did that, we did this, quantified, yes, we did that. Yeah, we did that. No, that actually is it. Oh, wow. Oh, fun English class today, guys.
Can you scroll back up?
Yes, yeah, of course.
That's right now, example 4.
Yeah, it's fine. Go ahead. I mean, I'm teaching you what they want me to teach you. I don't know what else to say, though. And have y'all been doing the homework? Are y'all all caught up with the homework?
Yes.
Yes?
I'm just taking.
Well, it doesn't mean not all the way caught up, but y'all been doing the lessons, right? At least some of the homework. Has there ever been anything on the homework that we did not talk about in class?
I guess.
Not really?
Well, there was a
No.
paragraph. There was paragraph.
Everything?
There was a.
Okay, I just make sure, like, these lessons are about 20, 30 minutes long. I make sure I'm not, like, skipping something, you know?